So my presentation is like an example of how we use the data in FishBase to help us with the management of some resources. So we did this study because there was a lot of data that's available in several databases done by, for example, in the Caribbean, done by the Healthy Reefs Initiative in Belize and the Perry Institute of Marine Science in the Bahamas, that these institutions use to estimate the biomass of fish that they observe. But these are all visual census surveys. And sometimes we think, well, we cannot really use the visual census surveys for, say, doing length frequency analysis. But there is this method, Beaverton and Holt, and that was published in, I forget, when was it, Diane? 1956? 57. That actually is very straightforward if we had length frequency analysis. Normally, the length frequency data that is used are from surveys. So most of the species in the Caribbean, for example, especially in the Barrier Reef, the Caribbean Barrier Reef, do not actually have that much information and much less data on catch. So these are the two things. So we have Belize and the Bahamas, and we picked that because we had collaborators in those countries, but you can see it's the inner and then the outer part of the Caribbean, and this is what I was talking about. 1956. It was 1956. Beaverton and Holt. And if we had estimates of asymptotic length L infinity and K of the von Bertalanffy growth function, we would be able to apply that to length frequency analysis that we get from the visual census surveys, and for which we can then see the length from which all of the fish are seen, and that's the L prime in this equation, and then the lengths used to compute the L mean, which is here in this equation. So it's very doable. Then after that, we can use the Pauli 1980 equation to get an estimate of M from the fact that Z is the sum of natural mortality M and fishing mortality F. Now, as I said, the data sources are this is from Belize. The data sources are from the visual census done by the Healthy Reefs Initiative, and for several countries in the Western Caribbean, but including Belize, so they had more data for Belize. And that data was available already from 2006 to 2021. And 2006 to 2021 are the data that we used in this analysis. And then for the Bahamas, it was the data that was curated at the Perry Institute for Marine Science, plus the data that they had encoded into the AGRA database. Now they had the Bahamas, the Perry Institute had data for 2011 to 2013, and another group of data for 2015 to 2019. So this is the period that we used in this analysis. For the Beaverton and Holt, the thing is that we need to have estimates, or we need to have in the sample the maximum length of this individuals sampled to be at least 50% of the total length of the expected maximum size of the species. So that's how because they had lots of species. There were like 60 species altogether in that data set, but not all of them had been observed with maximum sizes that are 50% of the expected maximum size for the species. So after that, we estimated the percent difference between the two estimates of Z. For Belize, it was between 2006 and 2021, and then for the Bahamas, it was between those two time periods. I was thinking, okay, how do we know that the Beaverton and Holt results are acceptable? So we had, for Belize and for the Bahamas, as other data sets. So there was catch, reconstructed catches, first thing. And for Belize, we were lucky enough to have length frequency data that were obtained by Alex Stoifik, who is a collaborator, in between 2016 and 2018, I think it was. And he measured from the market survey 18,500 fish samples, from which he was able to do a length frequency analysis. And then also for Belize, we actually had a few catch data, reconstructed catch data, that were analyzed with CMSY++ method that was discussed by Costas yesterday. So this is just an example, a handful of the length frequency data from Belize that was from the HRI database, and you can see we could do this for 2006 and 2021. So the top is for 2006 and the bottom is 2021. Just looking at the length frequencies, you can already see that there's a difference. And this is the result of the analysis for the HRI data. And we have here the F for 2006 and the F for 2021, and then the estimated percent change of that. Just to note that you have a very big change, a positive change, and therefore an increase in F for the lane snapper here and for the striped parrotfish. Both lane snapper and striped parrotfish are missing lots of catch data in Belize, at least for Belize. But I just want to mention that there is this the mutton snapper here, which is indicating or suggesting a decrease in F, minus 53%. But for 8 of the 13 species that we were able to analyze using this method, there was an increase in F. This is the Bahamas database, the results of the Bahamas analysis. Here, for only 5 species, because these were the species that responded to the criteria that we had for the length frequency analysis. Already you can see there's lots of changes there. Here you have, so you would expect to have an increase in F, just looking at the length frequencies. But actually, we had 3 of those species had an increase in F. And, Z, I wasn't able to estimate F. So an increase for the lane snapper and the yellow snapper and the gray snapper. And a decrease in the red hind and schoolmaster. Now, the decrease in F, we don't know what's happening with that. I still have to look into that, why there's a decrease. But there is a trend that we can see. Now, this is the data I'm going to compare them with, right? So you have this set of data that were coming from Alex Stoifik's market analysis, and you can see, I did not put the length at first maturity lines, but you can see that the large part of the samples were fish that had not yet reached maturity. And this is an example of what we did. This is only for Belize. I don't present to you what I did for the Bahamas. But, so this is a result of the length-based Bayesian model that Costas discussed yesterday, LBB. And then we fortunately had, for the same species, estimate of using BSM. So that's the catch-based Schaefer model of CMSY++ BSM method. And you can see that the results are similar, right? And for lane snapper, yellowtail snapper, they are indicating high F, which was what we got from the Beaverton and Holt method. And you have the mutton snapper, that remember in Belize it had a decrease in F. So the mutton snapper seems to be, for some reason, in the recovering phase of if there was anything that was being done for it, then it's working. But I don't know. So that I cannot tell you yet. I'm not done with the analysis. And so the take-home message is that the straightforward Beaverton and Holt model can be used to analyze length frequency data from visual census surveys to generate insights on the status of the coral reef species for which we have very little information in those countries. And then for the species that have comparable data sets as the one that we presented for Belize, we can see that there is a relationship between the results, or the relationship, but the results of the LBB method and the BSM method sort of confirm that there is an increase in F, and so confirms the Beaverton and Holt results. And I was just wanting to show that the Beaverton and Holt model, if we can estimate the F, would be a way to go if we don't have catch data for the analysis using CMSY++ method. That's it. Thank you.